This tutorial will show you how to use EDPIV to interrogate an image at two different spatial resolutions, and how to use coarse spatial resolution as an estimate for a finer spatial resolution interrogation. Alright, as an example, I'm going to use homework 5 from my 2016 PIV class. So I'm going to start by opening the pictures that for this case. So those are, I loaded those two in. Now I'll go to evaluation, and I always like to turn off the grid. Now I have previously interrogated this image at a 64 by 64 pixel using 64 by 64 pixel interrogation regions, and I'm going to load that result. So here it is, homework 5, case B, 64p. So I'm going to load that result. It was using a 16 by 16 pixel grid, and what you'll notice is that the final rows and columns of grid points are missing, and that's because the 64 pixel window from this, let's say, first row of points here would be out of bounds, would be outside the image, and so those points weren't interrogated at that 64 pixel resolution. But when I go to the 32 pixel resolution, I would like to push out to the edge of the image if possible. So what I'm going to do is make the code extrapolate and fill in these points. Alright, so the first thing I need to do is, as I discussed in a previous interrogation, is to reshape these vectors. These vectors right now are loaded in a 1 by roughly 4,000 vector column. And so you see M0, that's the current memory location that's being displayed. I have 3,721 points in 0 rows and 0 columns. And what that means is these are all, while these memory points are plotted on the screen, they're not in a form that EDPIV can use for a window shifting. So I need to reshape them, and the way I do that is by taking the current velocity field, the current displacement field, which is in M0. I'm going to save it into M1. I could also choose M2 if I wanted to. Now then I'm going to choose interpolation with the data in M1, and actually before I do that, notice that this final column of points has appeared. Alright, so now I'm going to interpolate with the data in M1, and the velocity, the displacement field that we had just a second ago has reappeared. But if I look at the info now, in M0 I see 4,225 points in 65 rows and 65 columns with 3,721 vectors. So that's just what I would expect. This, let's say, single column list of vectors has been reshaped into a 65 by 65 pixel matrix. Alright, but the measurements, or let's say the measurements along, in the first row, the first column, the last row, and the last column are still missing. So I need to make those appear. And the way I do that is by activating those points. So I will position my cursor in the upper left portion of the image and left click, and then come down to the lower right portion of the image and left click again. And you'll notice that the final rows and columns of points has appeared. And now I go to interpolate with current data, and I have filled in those the border rows and columns with, it's called interpolated measurements, but they're actually extrapolated because I'm asking for what the velocity should look like outside the region in which I have vectors. Alright, so this is now those border rows and columns have been filled in. So now I'm going to take that vector map and I'm going to put it into M1, memory location 1. And now I'll go to the settings and I'm going to do multi-pass, and you see I'll leave it at 32 pixel windows with a 16 pixel grid. The search radius isn't important. Search radius as small as 5 should be adequate here. And for window shifting, I'm going to start by choosing M1 because that is the memory that I put my displacement vector field into. And then I'll do central difference interrogation, continuous window shifting, 4-point image correction, and central difference image correction. And that's it. So now I'll click close, and I'll click start, and probably 5 iterations is enough to see good convergence. In order to make this go below a 3% convergence criterion, I'll set that to 0, then it'll execute all 5 loops, and click start. And you'll notice the little box, the little interrogation box scrolling around the screen. And now one thing that I could point out here while this is running is that you saw the little circle, which indicates maybe that a program is not responsive. But in this case, in EDPIV's case, all that indicates is that the program is not going to respond to you clicking until it has finished running. All right, and the statistics have come up, and you see the convergence is down to 0.04% between iterations. All right, but really the important thing, the goal of this tutorial was to show you that now I was able to interrogate these pictures at a 64 by 64 pixel resolution, which was required because of the large displacement in the images, that resulted in missing vectors near the border of the images, and I was able to replace those in a shifted file, and then use those replaced vectors to perform a 32 by 32 pixel window interrogation region interrogation. All right, that's it for now.